This week, we are learning chapter 8.4, perpendicular vectors. Before we start proving that the two vectors are perpendicular to each other, here we're going to start with an inner product, or you can say is a dot product. The formula for dot product A dot B is right here. When you are given two vectors a1, a2, b1, b2, you're multiplying the x together plus the y together. So for example, I want to find the dot product of -2, 3 with 4 and the -5.
Mama.
How to find the dot product? So the rule is to multiply the x with x plus y with y. We will have -2 times 4 plus 3 times -5. -8 plus -15. So total we will have -23. Okay, so make sure before when we're doing addition, subtraction, scalar multiplication, you always will end up with one vectors at the end, which you combine with two numbers, right? Here, make sure for dot product, you want only your final answer is only one number. So we use a dot product. A very useful way to use a dot product is to check if two lines are perpendicular. Here we have the line A, vector A, and here we have vector B. They are given two vectors here. So if these two vectors are perpendicular, we will know by finding the dot product. If your dot product is 0, which means that these two vectors are perpendicular to each other. Example 1. We are finding P, Q, M to check if any of these are perpendicular to each other. So first we can check if P is perpendicular to Q by using the dot product. That's one thing we have to check. And we can also check if P is perpendicular with M. Then the last thing we can check if Q is perpendicular with M. Okay, so make sure by the definition we had before, if they are perpendicular, we should have equal to 0, right? Okay, let's go ahead to start. P, let's write out the vector P, 7, 14. And 2, -1. So 7 times 2 plus 14 times -1. 14 minus 14. Okay, we are getting a 0, which means that yes, P is perpendicular
Mama, where's the Q?
to vector Q. You can pause here, try the other two vectors on your own. Okay, so P, vector P is 7 and 14. Vector M is 3 and 5. So 7 times 3 plus 14 times 5, 21 plus 14 times 5, which is 70. Together, we know definitely it's not equal to 0, so we say P is not perpendicular to vector M. At the end, we need to check if Q is perpendicular to M. Q is 2 and -1. Dot M is 3 and 5. Multiply the x with x, 2 times 3 plus y with y. So 6 minus 5, which is -1, is not equal to 1. So we say that vector Q is not perpendicular to vector m. Here is an example of how a vector looks like in a 3D space. The example here, we can see that we have a vector A from OA, right? Starting from the origin to A. The vector OA. Okay, how to represent this vector OA? We follow the order. We start with the x value, which we can see is 5. And then we go with the y value, which is up here, 8. And the z value, which is 3. So that is how we represent the vector OA in a 3D space. We are using the same formula. If we want to find the dot product of two vectors in 3D space, then we just do multiplying all the x together plus multiplication of the y plus multiplication of the z. Okay, I hope you guys can try that example here, example 2 on your own before I go over. We are finding the if vector A and the vector B are perpendicular. We have a -3, 1, 1, and the vector 2, 8, -2. To check if these two vectors are perpendicular, we're going to use the dot product. So we multiply the x together, -3 times 2, plus all the y's together, 1 and 8, plus all the z's together. -6 plus 8 minus 2. Total is equal to 0, so what conclusion can we make? Okay, now because it's equal to 0, we can say vector A is perpendicular to vector B. This graph is showing that if vector A and B are perpendicular and both of them are on the plane M, there will be another vector on top of the plane M that are both perpendicular to vector A and the vector B. Okay, so in here, all you need to pay attention to that is there will be a vector going up here. The name for that vector is A cross B. A cross B, which is representing this line up here, and that line is perpendicular to vector A, and that line is also perpendicular to vector B. Here is a formula to show you that how to find the vector A cross B. I'm going to show you guys step by step, but here I just want you guys to write down the formula, the next step here. So A cross B, you will have these matrices here, and I'm going to explain step by step, so no worries if you don't understand what's going on here. But then please write it down. The next step will be A2 times B3 cross multiply, and then subtract B2 times A3. And that will be multiplying with I. Make sure the second one is minus. Minus, then you cross and multiply again. A1 times B3 minus B1 times A3 times J, and plus the last one, A1 times B2 minus B1 times A2, and the last one will be multiplying with K. Example 3 want us to find the cross product of V and W, which are given here, and we need to verify that your answer, your final resultant vector, is perpendicular to V and W. The first step, we want to write out A cross B. Just put these two vectors on top of each other. We know that the first number we use I to represent, the second number we use J, and the third one we're going to use K. So the vector for A, in this case is V, right? We instead of A cross B, which is V cross W. So V is 1, 3, and 1. Literally put these two vectors on top of each other. Second vector is 0, 1, and 2. Okay, so now we're going to do it. The second thing is really easy, right? So I know it seems very complicated. So something with I minus something with J plus something with K. So what should we write the number for I? So what you can do is to cover the I term. So first set here we are finding I, so we're going to cover the item. I'm going to use a different color, for example, cover the item. So we only see 3, 1, 1, 2. That's what we're going to write down. The second set is for J. We do the same thing. So here is for J. We're going to cover the J term. So what we see here is 0, 0, 1, 2. That's what we are going to write down. The last set here is for K. So we're going to do the same, which means that covers the J term. Okay, so what we have is a 0, 0, 3, 1. That's what we're going to write it down. 0, 0, 3, 1. Now we're going to follow the same formula we introduced before, which is a cross, multiplied, and subtract. So we have a 3 times 2 minus 1 times 1. That is for I. Okay, make sure second term is the same, multiplied and subtract. I know 0 times 2 minus 0 times 1, and that's for J term. Oops, this is for J. I just realized that's not for I. Okay, I made a mistake here. Okay, and be careful. When you're doing the second term here, you have to have a parenthesis. Otherwise, you will make a mistake. You always put a parenthesis there. Okay, the last term, plus, we cross multiply and subtract. So 0 times 1 plus 0 times 3 for the K term. Okay, now we just need to figure out the answer. We have 6 minus 1, that is for I, oops, I, and the minus 0 for J, plus 0 times 1 plus 0 times 3 is 0 for K. So which means that we just have 5, 0, and 0 as our final answer for this vector. Second part of this question is to verify that our answer is perpendicular to the given vector, which is perpendicular to V and perpendicular for W. That always will be the case. So let's verify. How to verify when two vectors are perpendicular, which means that when we do the dot product, our final answer is 0. We multiply the x 5 times 0 plus 0 times 3 plus 0 times 1. Okay, everything multiplied together is 0. Okay, great. That means that these two vectors are perpendicular to each other. We do the same second term. So 5, 0, 0. Check if that is perpendicular to 0, 1, and 2. Multiply. 5 times 0 plus 0 times 1 plus 0 times 2. Okay, we get 0 again, which is what we want. Make sure when you're doing your practice, your formative and summative, for this type of question, you should always get a final answer is 0 when you're trying to verify it.